Hey everyone, welcome to our next video. So next up we're going to be talking about 1.6. Where's the notes at? There they are. All right. That was our last one from 1.5. So now we're going to be talking about 1.6. Now 1.6 is not a super long section. It's the fundamental identity and reference angles. So I've been watching some of the videos back, well, not much because I don't really like to listen to myself, but I tried to check the sound quality and stuff like that. And I do notice that I breathe a little heavy. I am pregnant while I'm filming all of these videos. So if you're like, man, she's breathing heavy, that would probably be why. It's just something I've noticed, recently, but so that's just a little bit into my life, what's going on while I'm doing these videos, but anyway, I thought it was a little bit funny. So let's get into our section. So 1.6. The first part of this, we're going to talk about what we call the fundamental identity. So we already know that sine of an angle is equal to y over r. I know that cosine of an angle is equal to x over r, and that's coming from 1.4. I also know that r squared is equal to x squared plus y squared. Sometimes we see it as r equals the square root of x squared plus y squared. Either one. I'm just going to use this version of it, for now, but it's just Pythagorean theorem. So something that I want us to look at is what happens if I square the sine, square the cosine, and then add them together. Basically what I'm doing here is I'm trying to repeat Pythagorean theorem, but using sine and cosine. So I'm going to write it in here. So let's say that we write sine of an angle squared plus cosine of an angle squared. And I want to know what this equals, because I want to know, is it going to be r squared, just like with the normal Pythagorean theorem? What are we going to see? So I can replace sine of my angle with y over r. So that's going to be y over r squared plus, and I can replace cosine of my angle with x over r. This is going to give me y squared over r squared plus x squared over r squared. Then I can write it as one fraction, so y squared plus x squared over r squared. Well, I know that x squared plus y squared is equal to r squared. So this will become r squared. So I get r squared over r squared. Anything over itself will just equal 1. So something that we learn from this is that sine of an angle squared plus cosine of an angle squared is equal to 1. Now a point here about notation. Another common way to see this written is sine squared plus cosine squared equals 1. This is really your more common way to see it, is this one down here. But I really want to make a point to tell you that this is not the same as saying sine of an angle like this. These are not the same thing. Because this one is saying square the angle and then plug it into sine and cosine. This one says plug in the angle and then square. So you want to be careful with how you write these. I also do not want you to write this. This is not the same thing. So this is bad. You don't want to write it like that. These are your two notations that are good to use. And so, of course, I'm going to do an example to kind of show you how to use this identity, but this is the fundamental identity of trig. So this is the fundamental identity. Sometimes it can also be called the Pythagorean identity. But we're mostly going to call it the fundamental identity. And so I want to talk about like what that means to be the fundamental identity. Honestly, it means that almost all other identities are coming from that one identity. So in chapter 3, which we'll do after test 1, we're going to learn a bunch more identities, and they're almost all coming from these identities, or they use them in some way. Like maybe they don't exactly come from it, but they use them like to get to the new identity. So these are this is a really important identity. And I will need you to know this for test 1. So you want to remember this identity. Okay, so let's do an example to show you like what this is even used for. So example 1, it says find cosine of alpha if sine of alpha is equal to 3 over 5 and alpha is an angle in quadrant 2. So there is another way to do this one not using the fundamental identity. What we could do is we can set this up as a triangle. So there's two ways. So if we don't use the identity, so not using identity, there's two ways. If we do it this way, I can use the fact that sine alpha is equal to opposite over hypotenuse. Also, I can draw my angle in quadrant 2. So I would say, okay, I have an angle in quadrant 2, but you have to remember that it has to be in standard position. And so the opposite side would be 3, the hypotenuse would be 5, and I get that because of sine. Now if I want cosine, then I want the adjacent over the hypotenuse. But I don't know the adjacent side. However, we can go get it using Pythagorean theorem. So I can say a squared plus b squared equals c squared. And I don't know, let me let this be, I'll say it's b, whatever you want to call it. So it'd be 3 squared plus b squared equals 5 squared. So 9 plus b squared equals 25. B squared equals 25 minus 9. So b squared equals 16. So b would equal 4 because I got to take the square root. Now you have to be careful here. When you take the square root, it's technically plus or minus. Now we want to think, should our b be negative or positive? like, are my x's on that side going to be negative or positive? And they are going to be negative, so that is technically a negative 4. So then cosine would be negative 4 over 5. So this is one way to do this problem. The other way is to use the identity. So we have this identity that sine squared of an angle plus cosine squared of an angle is equal to 1. Another way we can write this, remember we can write it as sine of my angle squared plus cosine of my angle squared is equal to 1. And so for this one, I can just plug sine straight in. So since sine of my angle is equal to 3 over 5, I'm going to replace this whole thing with 3 over 5. And then it is still being squared. Let me use another color maybe so you can see it a little bit better. I'll do blue. So since sine of my angle is 3 over 5, I'm replacing that whole thing with 3 over 5. Be careful here. Sometimes I'll see people do this. They'll say sine 3 over 5. No, please don't do that. It's saying that the whole thing is equal to 3 over 5. So you want to get rid of the sign in there. It's not giving you the angle. We don't know the angle. Plus, let me go back to green. Plus cosine of my angle squared is equal to 1. So I get 9 over 25 plus cosine of my angle squared equals 1. Subtracting, so I get cosine of my angle squared equals 1 minus 9 over 25. 1 can be written as 25 over 25. So I get cosine of my angle squared is equal to 16 over 25. Then I can take the square root. Square root of 16 is 4. Square root of 25 is 5. And be careful here, it's always plus or minus. We want to check what quadrant we're in to decide if it should be plus or minus. Since we're in quadrant 2, cosine is negative in quadrant 2, so this should be a negative 4. And so that's my final answer. So really this is just two different ways to do the same problem. I want to warn you that on the test, if I say to use the fundamental identity, I need you to do it using the identity, meaning I want it to look like it does in green. Now, I give partial credit, so if you did it like in the pink, you wouldn't lose everything. Like I would still give you majority credit for that. It's just you might lose 1 or 2 points for not using the identity. The reason that if I want you to use an identity, like if I tell you to, I would like for you to use it, is really to get you prepared for test 2. So test 2 is, it's a little hard, and we use a lot of identities and stuff, so I want to get you used to using them earlier rather than just throwing it all on you at once. So this is kind of a little bit of an intro into using identities. Next, we're going to talk about reference angles. So I'm going to write you the definition. Of course, I always call these like very mathy, like the mathy definition. So it says if theta is a non-quadrantal That just means not 0, 90, 180, 270, 360. None of the ones that are actually on the X or Y axis. In standard position, meaning touching the x-axis, like it's coming from 0, so this is my initial side, and the angle is wherever else. Then the reference angle, which we'll call theta prime, so it's like theta with an apostrophe, but we call that theta prime, is formed by the terminal side of theta and the positive or negative x-axis. Now, something I want to point out to you. I have already taught you this. I do this in 1.4 because it's just kind of natural. Like it just kind of comes up, So my hope is actually that what we're about to do is a review. It's maybe talking about it with a little bit of different language and stuff, but it shouldn't feel completely new to you. So for example 1, this would be example 2. We're going to state the reference angle and state the quadrant, the original angle is in. So we're going to look at theta equals 240 degrees. We'll do theta equals 11 pi over 6. We'll do theta is 690 degrees. In part D, let's do negative 5 pi over 4. So for part A, I'm doing 240 degrees. So this would be 180. This would be 0 or 360. So 240 would be in, you want to think about the quadrant. It comes after 180. It's not quite as big as 270. So it's going to be in quadrant 3. So I know that. It's in quadrant 3. Your reference really just means how far is that from the nearest x-axis. And so we've already done this. From 180 to 240 is 60 degrees. So my reference is 60 degrees. And so now what this tells me is that if I look for, say, sine of 240 or cosine of 240 or even tangent of 240 or whatever, it'll have the exact same value as tangent, cotangent, whatever we're looking at 60 degrees. So 240, I usually say that like this, it acts like 60 degrees. But The only difference is the sign. So because we're in a different quadrant, we may have to change it from positive to negative or something like that. Let's do part B. So this one's in radians, so this is pi, this is 0, wraps around to 2 pi. Since I have a denominator of 6, I would like my pi and 2 pi to also have a denominator of 6. So this would be 6 pi over 6. If I multiply this by 6 over 6, I get 12 pi over 6. So then I want to know, is 11 pi over 6 closer to 6 pi over 6 or 12 pi over 6? It would be 12 pi over 6, and it happens to be pretty close. And so the distance from 11 pi over 6 to 12 pi over 6 is pi over 6. So my reference is pi over 6. Just as a reminder, that equals 30 degrees. And I'm in quadrant 4. So now if we're looking for sine, cosine, whatever, of 11 pi over 6, instead of having to like memorize this or something, I can go reference my table and just look at 30 degrees instead. Let's do C together. So C is 690. That's too big. I'm not trying to graph that. So you want to think about what can we do to make an angle smaller if it's too big. And so I'll give y'all a second to think about it, pause, think. We can subtract 360 using coterminal. So if I subtract 360 from this, I'm going to get 330 degrees. And now I'm going to graph that. So that would be in quadrant 4. And sometimes I don't draw them perfectly, that's fine. So I'm in quadrant 4. And my reference says, okay, how far is it from the x-axis? So we don't want to measure over here, right? Because that's crossing into a different quadrant. We want to measure from like the closest place. So we're going to measure right here. So 330 to 360 would be 30 degrees. So my reference is 30 degrees. And we can do part D. So I have a negative angle for part D, negative 5 pi over 4. I don't like to work with negative angles. What I can do is add 2 pi using coterminal. So I'm going to add 2 pi to this. So that's going to be negative 5 pi over 4, plus this would have to be 8 pi over 4 to be able to combine them. And that's going to give me 3 pi over 4. So now instead of dealing with negative 5 pi over 4, I can just look at 3 pi over 4. So I know this is 0, this is pi, this is 2 pi. I need a denominator of 4, so I'm going to multiply both of these by 4 over 4. This gives me 4 pi over 4. This one gives me 8 pi over 4. 3 pi over 4 is definitely closer to 4 pi over 4. And it actually comes right before it. So it's going to be like right here. So my reference here, the distance from 3 pi over 4 to 4 pi over 4, is pi over 4. Remember that that's the same as 45 degrees. And I was in quadrant 2 for this one. So this is how you find reference angles. And now again, the whole point of using reference angles is that, let's look at another example. If I say, like, find the exact value of the following, and we'll do a few of these. So let's see, I'm going to do I'm going to work with the ones that we just did. So let's say I want sine of 240 degrees. B, we're going to do, what was the angle in B? 11 pi over 6. Let's do, I'm thinking, let's do cosine of 11 pi over 6. And I don't want to run out of, I don't want to run out of space, so I'm going to use these for now. So sine of 240. I just discovered that my reference is 60 for this. So this is 180, this is 240. We said that my reference was 60. This means that to get this value, what I really want to come back to is the table. So I have 30, 45, 60, sine, cosine. This is 1 over 2, root 2 over 2, root 3 over 2. This is root 3 over 2, root 2 over 2, 1 over 2. So if I'm looking at sine 60, square root 3 over 2 is my answer. So this would equal square root 3 over 2. But I have to check the sign. So remember I taught you in 1.4, all students take courses. So in quadrant 3, only tangent and its reciprocal are positive. So this one's going to have to be negative. Cosine of 11 pi over 6. We said that that was in quadrant 4, because this is 0 or 2 pi, which can be written as 12 pi over 6. This is pi, which would be 6 pi over 6. So 11 pi over 6 is in quadrant 4. My reference is pi over 6, and I also reminded us that that's the same as 30 degrees. So that means that I'm going to come to my table, and instead of needing to memorize what 11 pi over 6, what cosine is, what sine is for that, I can just say, okay, cosine 30 degrees, okay, it's square root 3 over 2. And so then we need to check the sign. So let's see, all students take courses. So in quadrant 4, C is positive. So that means cosine and its reciprocal secant are both positive. So this is going to stay as positive in quadrant 4. So I hope this is making sense to you. It's really just so that you don't have to memorize everything. Because I'll show you, if you want to memorize all of it, how much it is that you're going to have to memorize. Well, that did not do what I wanted at all. Why didn't it take the lines? I'm trying to bring it down. Okay, there we go. That's kind of weird. Let's do part C. I didn't mean to turn it white, but that's fine. So part C, let's see, for those angles up here, what did I do? 690 and negative 5 pi over 4. Uh, let's do a cotangent, because why not, of 690. And for part D, let me ask tangent of negative 5 pi over 4. And so just to be clear, I mean, I'm just picking some, but sometimes the sine and cosine can go well, but maybe the tangent and cotangent don't, or the secant and cosecant and stuff. So 690, we said we would do 690 minus 360, so that's 330. So that's going to be in quadrant 4. Has a reference of 30 degrees, and we discussed that already. So I need to know what is, instead of having to think of cotangent 690, instead of having to think about cotangent 330, I can just think about cotangent of 30. Now remember that cotangent is cosine over sine. So this is going to be 1 over 2 over root 3 over 2. So if I write that out, 1 over 2 over root 3 over 2, this simplifies to 1 over root 3. In quadrant 4, only cosine and its reciprocal are positive, so that means that this is going to have to be negative. Cotangent is a reciprocal of tangent, so it's only positive in the first quadrant and the third quadrant. Now be careful, my math lab will make you rationalize this. I don't really mind if you don't, though. So again, the way I got cotangent is I remembered that cotangent is cosine over sine, because tangent is sine over cosine. So cotangent would be the opposite of that. Now tangent, 5 pi over 4, so I'm going to draw it out again. So we said negative 5 pi over 4. We added that to, we added 8 pi over 4, so we got 3 pi over 4. That was in quadrant 2. We said the reference was pi over 4, or 45 degrees. So I'm going to look at 45 degrees here. Oh, I just realized that I made a mistake on part C. I'm going to go back to it after I finish part D, okay? I just made a mistake on it. I'm going to fix it. If you know what it is, great, and I'm sorry for making it. It happens. I want to make it clear to you that I definitely make mistakes myself. As long as you fix them, it's okay. Even if you make them on a test, make sure you go back and check your work and try to, find these kind of mistakes, because it's so easy to make some. So for part D, I'm looking at 45 degrees. Well, tangent is sine over cosine, so I would have root 2 over 2 over root 2 over 2. That simplifies to just 1. And tangent is going to be positive in quadrant 3 and quadrant 1, so it's going to be negative in quadrant 2. So let me go ahead and fix my issue in part C now. So here's what happened. See how it's a 30-degree reference? I accidentally looked at 60. So I did cosine over sine, but I was looking at 60 degrees. So I looked at the wrong reference angle in my table. So I'm going to erase this. I'm very sorry. It does happen. And I don't want to edit it out or anything because, I want you to know that it's fine if you make a mistake. Just make sure you fix it. So since my reference is 30, I should be looking at 30 degrees here. And I'll still do cosine over sine for cotangent. So root 3 over 2 over 1 over 2, which will simplify to root 3, and it is still negative. So again, that's my bad. Part C, I had made a mistake. My hope is that you noticed it and you were like, probably telling me from the other side of the screen. If you didn't notice it, then it's a good learning experience. Let me show you something real quick before we finish up this section. So I'm going to look something up for us. Oh, this is the Canvas page. So I'm going to look up the unit circle. So I want you to see this for a second. You see how this is so intense to look at. You see how this one, it has all the points labeled. It has 30 as pi over 6. It's got 45 as pi over 4. It's got 60 as pi over 3. You go around to the other quadrants. It has all of it listed. There are some people who will tell you to just memorize this whole thing. Can you believe that? Some of you, maybe that was you. Like you were told to memorize this whole thing. I think that that is insane. All you need to know is really the first quadrant. You just need 30, 45, and 60. Now the points are written because remember it's a cosine comma sine point. So this is saying like at 30 degrees, it's saying that cosine of 30 is root 3 over 2, sine of 30 is 1 over 2. So all these points are cosine comma sine. I think this is nice to look at, but when you think about actually learning all of these angles, I don't want you to memorize this entire thing. If you do, by all means, good for you. I hope you don't forget it though. I think that's the issue, is if you don't have a good understanding, you might forget it. But if you can just say, okay, I'm looking at, let's say for instance, 150. Oop, I didn't mean to click on it. Let's say I'm looking at 150. Well, 150 to 180 is 30 degrees. So I'm going to go look at my table and I just look at 30 degrees, right? You don't have to have it memorized for every single angle specifically. So this is why reference angles are important. They just make it to where you don't have to memorize this whole thing. So I hope that it goes okay, like practicing these and stuff as you're going through the notes and going through the homework. I just want to remind you that if you are having any issues at all, please reach out to me. Please, we can schedule an office hours appointment. I can get on Zoom with you. I do not know why this is not showing up. There we go. Sorry. I can make a Zoom appointment with you. I can meet with you in person if you'd like, because I like to do videos and stuff at my office. I don't really like to do it at home. My cat likes to walk across my screen and he'll mess me up. So I'll be here. I just want you to know that just because it's an online class, I'm still here to help you, okay? So please let me know if you are needing anything. So that is it for 1.6. That also concludes our videos for week 2. So I hope y'all are having a good week. And yeah, I'll see you in our next video.